Okay, so we are done with link layer. So what we have seen at the link layer are two attacks. One is this MAC flooding attack, and then we also saw ARP spoofing. So these two attacks are at the link layer. Okay. Now let's look at the network layer. Okay. Network layer, again, what we are going to focus on at the network layer is the DHCP protocol, and we will see some attacks against DHCP and similarly some defenses against that. Now DHCP protocol, people know what DHCP does. What is the DHCP protocol? Yes. So this is again something everyone is probably aware of. So what does DHCP do is it gives you an IP address, because without an IP address a machine cannot communicate with anyone. That is how things have been designed. So whenever you first connect to a network, you need an IP address, and of course you could manually configure your IP address, but manual configuration is prone to a lot of errors. What if you take someone else's IP address? Then there will be duplicate IP address. So that way automated is better. You will also make better use of resources. For example, IP addresses right now with IPv6 it is not a problem, but IPv4 addresses are very scarce, okay, and you want to pool them and reuse them, because not all people need addresses all the time, okay. Whoever is currently active, you need to give addresses only to them. So that type of pooling of resources DHCP does. So again, let's understand a little bit of how this DHCP protocol works. So when this is machine A and this is the DHCP server. For now, let's assume that the DHCP server is in the same local area network. It doesn't have to be. I'll tell what happens if it is not there, but for now let's assume that it is in the same local area network, okay. Now when a machine A boots up, it has no IP address, okay. It will have a MAC address because that comes with the hardware chip, okay, but it will not have any IP address, and it needs to get hold of an IP address. So for that, it basically sends out a DHCP discover message, which is a what type of, what will the destination. So this DHCP packet, when it is doing, again it's a IP, so DHCP is a network layer packet. In fact, DHCP is an application layer protocol which uses UDP and then sends this packet, okay, but let's focus on the network layer. In the network layer, the source IP, what will A put? Does it have an IP address? It doesn't have any IP address, so it will put blank, doesn't have anything. Whereas the destination IP, what do you think it will put? Huh? How does it know? You don't, when you are starting, you are like a baby, you know nothing, okay. So a newly booted thing doesn't know any whatever. If it could know the IP address of the server, it could figure out its own IP address. So it doesn't know anything, okay. Where the server is, nothing it knows. So because of that, it is having to broadcast this. So you use this broadcast address, which is 255.255.255. That is the broadcast address, okay. Now this, when it goes to the link layer, MAC, you can put your own MAC because that address you will know. So this is MAC of A, whereas again the destination will be a link layer broadcast, which will be FFFF, okay. What this ensures is that this DHCP packet is sent to all the hosts that are part of that local area network, and assuming the DHCP server is also there in that local area network, the DHCP server will also get this packet. Others will ignore, whereas DHCP, because it is a DHCP packet, it will act on it, okay. It is now going to see, okay fine, that this guy wants, and it will give it an offer, okay. It will basically, again this offer is also broadcast, to everyone because there is no IP address for it to send, because this guy cannot directly send it to it. It's also, it doesn't have any IP address, so it will broadcast. Okay, and within this offer, it will take, okay, you can maybe take this IP address. But the way DHCP is, then this guy explicitly requests that particular IP address. It will say, give me this IP address. This is also broadcast. All this is broadcast in fact. And then it will say request, it will do this reply where it will ACK that yes, take that particular IP address. So this is a DHCP ACK. Okay, so this is how DHCP protocol works. That's how they have designed it. Okay, so there is a discover, there is an offer and an explicit request based on the offer and an acknowledgement for that. After this point on, it will start using the IP addressing. Okay, so as you can see in this DHCP protocol also, whenever you are getting an offer or whenever you are getting whatever this reply, whatever it is, the way it has been designed again with no security in mind. If you send a discover, someone gives you an offer, there is no authentication. Did this offer really come from the DHCP server or did it come from someone else? You don't care too much. You will just act on that offer. Okay, so that's the basic protocol. So within this also there are multiple attacks. So one attack, as the name suggests, starvation attack. Okay, so what does the name mean? What does starvation mean? What exactly are you doing? So DHCP starvation attack is where you are starving. So remember, DHCP server has a pool of IP addresses that it hands out. Okay, and what you are doing in the DHCP starvation attack is exhausting that pool. So much like before, Mallory will keep asking, give me IP address, give me IP address, give me IP address. And that guy will keep giving out all IP addresses. And then he'll have no more IP addresses to give it to the right person. Okay? But this attack is not as easy to launch. Again, one of the reasons is the DHCP server, whenever it receives this discover offer, inside it you also specify what your MAC address is. And it will maintain a mapping. For this MAC address, I have assigned this particular IP. So for the starvation attack to succeed, what does Mallory need to do? It has to use many MAC addresses and accordingly whatever. So now this MAC limiting that we have done before, okay, that can help to some extent. It will drop if someone is sending too many link layer things with this MAC addresses, like as I said, this, if it keeps changing, okay, you are not going to, as in it will drop it. So you can prevent it, but then there is a subtlety here. It so happens that in the case where, so here is Mallory that is sitting here and this is a router and somewhere else the DHCP server is sitting. It is not sitting within your local area network. Okay. Now this DHCP server, because it is outside, the MAC address that the DHCP server is going to see belongs to who? The source MAC address. Whatever packet the DHCP server sees, the source MAC address will belong to who? Will it be Mallory's? Whose address will it be? Routers. Or some, yeah, basically this router is the one that is interconnecting. So this will become the routers. You are now, no matter how many MAC addresses this guy, whatever uses, they'll all get translated into one. So the DHCP server is no more able to see the MAC address anymore. Okay, because of this reason, inside the payload, so there is a DHCP packet, as in which is the application level payload. Within this, you have to specify what the MAC address is. Because in this situation, the DHCP server needs to maintain such a mapping. And it can only map, and now the MAC address is not preserved as part of the link layer header. So you have to put the MAC address inside the application payload. I hope you understand what. So DHCP is generating some message saying my source, I don't have any source IP, or in the past if it had some IP, it will say my past IP address was this, something and all it will generate. Okay, this packet when it goes down the protocol stack, you are adding other headers, you will have network layer, link layer header and go on. Okay, when I say this MAC address is also specified in this higher level message that DHCP is generating, which goes down the protocol stack where you are adding other headers. And the DHCP server does not have access to these headers, but it will have access to the payload. I mean, payload is like HTTP, that GET request is a payload of HTTP. Just like that, this guy is also generating some payload, DHCP is generating. So because of that, that MAC address is actually inside this. Now given this, Mellery doesn't need to change these MAC addresses again and again. It can stick to one MAC address. But what does it need to do then to launch the starvation attack? The link layer header, it will stick with one MAC because the switch will drop it otherwise. So link layer, it is only going to stick with one MAC address, which is its own whatever thing, but it wants to do the starvation attack. What can it do then? What does it have to change then? In the payload that it is generating, within that it will keep changing the MAC address. Many MAC addresses it will change. Okay, so basically what it is doing is it will generate one DHCP payload where it will specify MAC address is A. Then another DHCP payload it will generate, within that it says MAC address is B, whatever it is. These payloads, when they are going out at the link layer, the MAC address there may be just M's. Okay, all of them will have only M. So the switch will not drop these packets because that MAC limiting, here only on that port only M address is appearing. Whereas these packets, when they get forwarded over the router to the DHCP server, inside it they are basically seeing multiple MAC addresses. And for each of them it will assign one IP address and pass. Thereby the pool of IP addresses will get exhausted. No, DHCP payload is being generated by Mellery. What does DHCP payload mean? Maybe this is, so DHCP as I said is an application level protocol. So Mellery is generating some payload, within that it put MAC address as A. A as in, okay, MAC address as X, doesn't matter, some or let me use MAC address 1. Okay, this payload is application layer. So the application is generating this data. Now you are adding, because if it is using UDP, it will add a UDP header, then it will add a network header, then it will add a link header. Within this link header, it will use its MAC-M. Now this packet will go to the router and get passed on. So the DHCP server will see this packet alone, because all this will be removed when it is given to the DHCP packet, DHCP server. It will only act on this, and similarly it will generate another one where it will say MAC2 and again add all these other headers, which will be removed by the router, whatever it is, and then passed on higher up. Then this DHCP server will again see only this payload. Yeah, they do. That is what I am saying. That is why this doesn't matter anymore. The DHCP server is only going to act on the payload, which the other endpoint has generated. These addresses have no bearing as far as the DHCP server is concerned. It won't even see the MAC address, because they will be removed at the lower level. Right? Router has already changed the MAC address when it is sending the packet, and the DHCP server at the lower layers of the DHCP server itself will remove all the link MAC headers and all. It will only see, the DHCP server will only see the application level data, and within that the MACs are varying, MAC1, MAC2, MAC3. So for each of them it will generate one corresponding IP and pass it, and thereby exhaust. So that is what is happening here. Is that clear? So this is, so basically the point that is being made is that just MAC limiting is not going to solve this problem. You have to do something at the higher, as in this particular case, the higher layer, which is the thing, it is seeing multiple MACs, so that is the specific problem. We will see the defense for this, but the problem is clear, what this DHCP starvation is doing. Okay? Now, what is the defense against this type of starvation attack? Again we have to, so this, if this is the case, how will you defend against this? At the transport layer you cannot check anything, because who has the visibility? Each one is doing their own thing, no? Routers are not generally supposed to look at, routers have enough headache of their own in terms of routing and all. So routers normally don't do it, but as I said, these are all problems. Like if people have launched these type of attacks, the only way something that can be done is, oftentimes what happens in these type of situations where the DHCP server is outside, there is often a relay, DHCP relay that is deployed here. Okay, this DHCP relay can actually see the link layer header, and then it will take note of, okay, this link layer header is in the payload is asking for a lot of different MACs, as in there is a mismatch between the link layer header and what is the MAC address that is being specified inside the payload, and that relay will drop those packets. So that is the solution that is currently done. DHCP, sir, yeah, relays are part and part, because the DHCP server is outside. If it is broadcast, someone within here has to relay that packet outside, right? Otherwise, no one is going to reply. So DHCP relays are very much a part of the DHCP process. Especially if the DHCP server is outside the local area network, you have to deploy a relay. Otherwise, the protocol won't work. Okay. So that is one attack. So now let's look at the other attack, which is the DHCP spoofing attack. This is something which we were talking about earlier, is that when the DHCP offer comes, you don't know who is sending this. It could be Mallory, right? Because there is no authentication, you will accept these offers from whatever machine is sending, and that can be quite dangerous. Okay? So the idea here is that you did discover, you got an offer. Now this offer has not come from the official DHCP server, but this offer has come from Mallory. And this again is an extremely dangerous attack, because DHCP, apart from giving you an IP address, it will also give lot of additional information. It will tell you who your default router is. It will tell you who the DNS server is. Okay? And if you are sending malicious, you can alter these also. What is stopping you from altering that? Not only will you say take this IP address, you will say use this as your default router, and this default router is pointing to Mallory's router. And you will say use this DNS, this is also being controlled by Mallory. In which case, whatever later packets this Alice is generating, they will all go through Mallory's router. And because you are compromising the DNS server also, if you are typing some bank URL, it will then tell approach this other IP address, which is your own thing. You have this kind of phishing is attack we will see. It looks exactly like the bank's website, but it is not, it is yours. And DNS, if you circumvent at that level, you cannot determine anything. There is absolutely no way you can even detect that some malicious thing is happening, because everything looks identical. It's at the IP level, things are changed. So because browser will still show SBI whatever online whatever.com, but IP addresses where the packets are all going to Mallory's whatever machine. Okay. So, this DHCP spoofing, what I want to emphasize, is a extremely dangerous attack, because not only do you find you give an IP address, what is the big deal? It's fine, it will use that IP address, but importantly, because you are sending this extra information, which can be extremely dangerous. You can capture all the traffic of this user, not just capture, you can also pretend to be someone else, because you have compromised the DNS server as well. Okay. This is happening because there is no authentication for the offer. Now, how do you solve this problem? Again, switches to the rescue. Switches have to do something else. So, what do switches do? So, let us again look at the switches. So, let us say this is the DHCP server, and this is Alice that wants, and somehow Mallory is sitting here and is passing offers to Alice. What can switch do? Remember, in this DHCP message, you do have DHCP discover, offer, request and ACK. These are the 4 DHCP messages that are sent as part of the DHCP protocol, and Mallory will send these offers and ACKs in response to the discover and request, thereby compromising. What can you do to solve this problem at the switch level? That doesn't, in this case, it doesn't help. How does it help? IP address and MAC. Mallory can always spoof whatever it is. How does a switch? No, it can take on the DHCP's MAC and send. It's not going to help. This is not the starvation attack. This is just a spoofing attack where in the offer it is giving an IP address but giving malicious router and DNS servers information. So basically Alice may potentially get 2 offers, but that is also in some sense a feature of DHCP protocol that it supports. So oftentimes in networks you don't have to, there is nothing saying you have to run only one DHCP server. In fact, lot of organizations will, for reliability purposes or whatever it is, will always have multiple DHCP servers which operate over different pools of IP addresses. So multiple DHCP servers being part of the same network is very much valid. So you really cannot say that, if you are seeing 2 offers, it is also possible. Multiple DHCP servers may send multiple offers. You will accept one and reject the other. All I am saying is that is allowed as part of the DHCP process, which makes life a lot more difficult. You still have to solve this problem. So I think you are getting there. So basically the way you do this is through something called trusted ports. Okay. So the sysad again, when they are configuring this with this switch, this particular port, let's say this port number is 12, they know that on port number 12, they are connecting the DHCP server. Okay. They know they didn't connect any on this port, they didn't connect DHCP server. So what these do is any offers or ACKs, they will not allow on that, other than on the trusted ports, they will not allow these offers and ACKs to be sent on any other port. So for example, if this guy sent offer, this switch will drop that because that is not a trusted port. Whereas this switch, because it has been configured that this is a trusted port, this will allow offers and ACKs. But the other ports it is not allowed, they will get dropped. So that is how you handle this particular problem. Okay, again, as you can see now, when switches were built, they were built very simply. But as we saw, MAC flooding, this, that and whatever you have, switches now have to do lot of heavy lifting. Now switches in this particular case are not supposed to look, and in general switches are not supposed to look at higher layer data. They are supposed to only look at link layer headers. But now because of the security issues, they are now having to look at whether it's a DHCP packet or not, which means they are looking at higher level data. They are no more concentrating on just the link layer headers. That is the complexity which we call this violation of the end-to-end principle and things like that, right? So these are not allowed, but for security purposes, we are having to allow. Otherwise, internet won't work. Okay, so that's the idea behind this. So with this, we are done with the network layer attacks as well. We'll then look at transport and application layer.